Hello, hello, hello. Last session of the con. It's a lot of pressure. I feel like I have to tie everything up that's happened here. I hope you've all had as much fun as I have. This has been a great con for me. Yes? Good con? Good con? Yeah. Yeah. All right, so I'm here to talk about package management, the new era of it, which is a thing I think we've all been waiting for a long time, maybe. We're now solidly on the road towards new official tooling for package management. It's going to be a real sea change for the community. Come on, that's applause for that. I feel like we should be excited about that. Yeah. It's going to be a real sea change. At the same time, still, package management, kind of narrow, maybe an odd topic for a closing keynote. I don't know, at first glance. So I actually think, though, it speaks to something pretty universal. And I want to start by making sure that we are all on the same page about what package management is fundamentally about, and why it matters, and the history, and all that sort of stuff. So, all right, I think I have this down basically to 3 steps. We'll see how I do. Step 1, we write code. Step 2, we pull in other people's code because, usually shipping software is not an academic exercise in which we write everything top to bottom. And step 3, the pain begins. There's a lot of different forms of the pain. There's reproducibility issues, is the thing that's on my development environment the same thing that ends up in production or the same thing that my users get. There's managing the updates that come from upstream when your dependencies change, especially when those updates break our code, sometimes in obvious ways, sometimes in horribly subtle ways that you only discover much, much later. Point is, package dependency management matters. These are technically 2 separate things. For the purpose of this talk, I'm going to treat them interchangeably. We all have to deal with these problems when writing software, no matter what language we're in. And it's always a drag, because package management issues are never the issues we actually want to be dealing with, unless you're me. But apart from that, we never actually want to be dealing with these. I mean, by definition, struggling with package management is an exercise in yak shaving. But it's more than just the pain points. The pain points matter, and we need to address those, and that's part of why we all care about this a lot. But when we think about actually developing comprehensive solutions for package management, we're really talking about building tools that are going to change the way that we interact with each other. New tools are going to mean new expectations that we have of each other, new norms, new social protocols. Because, as has happened plenty times in the past, new tools end up creating new social systems, new expectations. Telephone was invented in 1876. It took a while for it to catch on, but once it did, coordination and passing information from home to home suddenly was a thing. And you have the way that cities get built change, the way that people work, and all of these sorts of things that fall out from tools that change social dynamics. Now, the phone, of course, moved from the wall into our pockets and our hands. And so I'm an older millennial, which means that I remember setting a time and place to meet people. Some of you might not know about this. This is a thing we used to do. But before we could coordinate on the fly through 10 million different possible ways of communicating with people, we had to figure this out. Point is, dependency managers might be the most boring social tech ever, and that is a low bar because the Yo app existed. That's a real thing. Just send Yo to people. I don't know it's a real thing anymore. But it's still a social system, dependency management tools, because they mediate and they coordinate the interactions and the relationships between people who are writing software. Us. Now, I could leave it there, but I'm a linguistics nerd, and I want to go a little bit deeper. And I want to talk about pigeons. Pigeon languages, not the bird. So a pigeon language is a language that emerges when 2 separate linguistic groups encounter each other with no common language. They have to figure out a way to communicate. So pigeon languages tend to be simplistic. No one speaks them natively. That's actually part of the definition of a pigeon. And they're often transient. They go away. But they're really not a strong foundation for culture in the same way that more general languages and natively spoken languages are. A really common place that they emerged historically was along trade routes, like the Silk Road, which is kind of legible there. But Many pigeons were used there ad hoc and came and went. So the reason I bring up pigeons is because when I think about the history of Go as a community and the software ecosystem that we have, it seems to me that we have been without a common language for sharing the code that we have. We've been hacking together transient pigeons when we want to share our work. And now that we are moving towards official tooling, I think a lot of these pigeons can go away. And we can all start speaking a real language with each other. And that's exciting, not just because the pains that we've been having go away, but because, I have no idea how much better this already awesome community and the software that we make will get when we are all speaking the same language to share our code with each other. The title of this talk is The New Era of Go Package Management. I think the easy way to look at that is there was an old era of package management, and now there's going to be a new era of package management. That's a valid reading. The one I like more is what we're looking forward into is a new era of Go and the community and the software that we create. And that is going to be, at least in part, defined by our ability to share code with each other better. OK, so at this point, I'm like perilously close to saying that dependency management is going to make the world a better place, like some CEO from HBO Silicon Valley or something. So I'm going to pump the brakes, and I want to bring us back down to earth a little bit. And for that, I want to talk about some of the fundamental issues in history that brought us to where we are today. So the roots of the problem, and this is whole talks have been given on this, of course. So this is the super fast version, is that we have GoPath, which only allows one version of a given package to exist at a time. That means that we end up having to resolve, if I'm going to go get Kubernetes over here and InfluxDB over there, if there's any shared dependencies between the two of them, well, the two might have different expectations about what that shared thing should be, and that becomes my problem that I have to manage inside my GoPath. There's no reproducibility built in with the tools that we have. GoGet doesn't do that. GoGet thinks it's fine. Yeah, we'll grab the latest version of whatever those dependencies are, and it'll work out. The fact that GoGet doesn't really care about anything apart from the latest tip of dependencies makes releases more or less pointless to roll, because the official tooling won't pick it up, so why are we doing that? And because releases are something that there's these disincentives against rolling them, it also makes our updates a crapshoot, because the releases aren't there, so we end up usually depending on whatever random version happened to be at tip on a Tuesday of the dependencies that we pulled in, and then when we update, well, it's whatever random version at 2 a.m. on a Thursday, or whatever. Now, it's important to say that we have also been hardened by these realities. As a community, we've been struggling with this, for some years, and there's a lot of really good culture that's come out of that. The proverbs about dependencies not being free and that you should be thoughtful before pulling them in, they're still true, and they will continue to be true even in this much vaunted new era. It's also true that it's not a great idea to break your API. We will have structured ways of doing that, but it's still not a great idea to do, because it creates a lot of complexity. But this is a good thing that we have developed these values, these ideas, I think, in our culture. I suspect that we will be able to handle some of the difficulties that can arise that other language communities have seen, perhaps somewhat better. I'm really not a fan of doing a language bashing thing, but I think we have some strong values around the way that we work with our dependencies that will serve us well, even in a world with a robust official tooling. So, OK, quickly, the tools arose to address some of these problems. Some focused on all of them, some focused on a subset. They made things enormously better, although still not solved, at least in part, because the tools often made slightly different trade-offs, making them incompatible in subtle or sometimes significant ways. GoDep was the first and continues to be the most widely used solution today. Its main focus initially was dealing with the reproducibility problem. I want to have the following SHA-1s for all of my dependencies. We'll record that and we can rebuild it elsewhere. It also dealt with the GoPath issue by initially allowing, you can restore into your GoPath or you can do fun import rewriting. Don't do that anymore. But GoPackage.in was, or is, a complementary solution to any other existing tool out there. It just lives in your imports, of course. But it deals with some of the multiple versions on GoPath issues just by hoisting version information up into the name. GOM and Glide were both explicitly modeled after tools from other languages like Bundler and NPM. And they allow the user to interact with released versions, which, great, except of course, we still have the disincentive against creating those releases in the first place. GoVendor, especially adept at the encapsulation work that GoDep was somewhat clumsier at. And GB, of course, a whole alternate toolchain that is a subset of what it does is deal with dependency management. So in 2015, with Go 1.5, the vendor directory was first introduced. The vendor directory is a place where you can take your dependencies, put them, and then import them at their normal paths without having to change any of the normal import paths in your code. The major tools adapted quickly. This is why GoDep doesn't have to worry about import path rewriting anymore because there's special support. Vendor, however, introduces its own problems. Mostly what happens there is you have issues with nested vendor directories. If I depend on some project A and A commits its vendor directory, then when I pull A in to my vendor directory, there's another vendor directory inside of there, and it's using things from there, and that can result in type incompatibilities, basically unresolvable type incompatibilities. It also has risks with respect to global states that should not be declared that should not be declared twice, or init functions that should not be run twice. So we in the space, the tooling space, had sort of seen these problems coming for a while, but when vendor was turned on by default, the shit kind of hit the fan. We saw people encountering these issues much more frequently. Now, 2016, we had been having a lot of good discussions already within the community of folks who work on the tooling. But when vendor turned on in that way, it sort of galvanized us forward. At the same time, so we were facing a risky moment in mid-2016, right? Because this is usually how things go. When you've got a lot of people with a lot of strong opinions about the way that a complex problem should be solved, is you just have somebody else show up and say, hey, this is ridiculous. Let's just do it this way. I'll make a new standard. The rest of you can go away. And inevitably, it just results in a new standard. So it is a testament to the awesomeness of the Go community and the people involved in this that this is not the situation that we have today. So drawing on the energy and the momentum that we had been building in these discussions through mid-2016, Peter Burgon put together a committee. I was on the committee along with Jesse Frizzell and Ed Muller and Andrew Durand. And then an advisory group which had Matt Farina and Daniel Theophanes and Dave Cheney and Steve Francia on it. I don't have those on a list. I know those from memory, really. That was charged with sort of considering all the things and putting together design docs, getting feedback, and implementing a prototype tool. So, the idea here was we're going to cover the crucial use cases of the existing tools, either directly or through some alternate approach, but not become a kitchen sink, because nobody wants that. We're going to try to validate some of the hypotheses about workflow, what that should look like, and how the system is going to work at scale. It's going to serve as a working prototype, carving a path for what the community wanted to see in the tool chain. It would minimize as much as possible any new rules and assumptions so that it remains maximally compatible with the tool chain and that moving into the tool chain should not be an arduous process. And it would provide flexible working code so that the toolchain would not have to start from scratch when we actually, went for doing that. Of course, it would also keep everyone happy at all times, unconditionally, and, reduce the gestation period of puppies to like 48 hours so that there is an endless supply of tiny little things that have paws so big they don't know what to do with them. Tall orders, right? So in January, we opened up GitHub Golang dep, which is the result of all those initial efforts. Today we call dep the official experiment. Those words are very carefully chosen, and one of the things I'm actually looking forward to most today is that I get to explain to a bunch of people in a clear way why we chose them and exactly what it means, but I'll get to that in a second. There was one other thing that I skipped in the constraints for this process, and that was the community. We wanted to be as inclusive of you all as we possibly could in putting this tool together. So before I go any further, I would really like to ask folks just to briefly stand if you have contributed code to dep, if you have commented on any dep issues, stand. If you participated in discussions in Vendor on Slack, or the Package Management Google group, or if you've responded to any of those dependency management surveys. Yeah? Yeah. All right. Thank you. We would not be anywhere without the community's participation on this. We have come a very, very long way, and we have a lot to be proud of. Okay. This is not the place for a dep deep dive. Carolyn Van Slick, one of our subsystem maintainers, is going to be doing a lightning talk on dep tomorrow. If you are interested, you should absolutely go to that. But I do want to cover some of the sort of fundamentals of dep so that you have a sense, just a high-level sense of what this all entails. So first, we have drunk deeply from the well of other languages experience. But what we built is very much tailored to Go. Probably the clearest example of that is imports are still running the show. You don't write into some metadata file that you want such and such dependency. We statically analyze your code, we look at your imports, and that's what you need. We do have metadata files, though. We follow what's called sometimes the two-file system. We have a gopackage.toml file in which you declare rules, constraints, like I want master of such and such, or I want anything between versions 1 and 2 of this dependency. And then we have a gopackage.lock file, which is generated by dep by going through. It looks at your imports, it looks at the rules, and it works out a transitively complete dependency graph at certain specific immutable revisions and writes out this lock file. This is what gives us reproducibility. Dep is project-oriented. We define project as a tree of packages at the root of which there is a gopackage.toml file. In almost every case, the project root is the same as the repository root. Semver tagging is the norm here. It's the expectation. Leading Vs. Dave Cheney has some great blog posts about this. Follow his thing. I'll say a little bit more about that later. But and dep is vendor-centric, which means that it's entirely built around populating the vendor directory. There is almost no interaction with GoPath at all. Caveat there, though, it is vendor-centric, but it has been designed carefully so that we can abstract from that in the future because there are plans to do so. Dep has 3 commands. Kind of 4, but really just 3. The 4th's going away. Dep status does your interrogation of your status on disk. Do I have dependencies that I need to update? Is there something missing from my vendor directory, which is usually impossible? Security issues, other kinds of things, we can go into status. Init is roughly get init. I want to make a new project. Dep init can also be run on an existing project. And for the moment, we have automated logic that will work out some initial hints or rules based on what's in your GoPath, or if you use GoDep or Glide, it will automatically convert the metadata from those systems. We want to add support for as many tools as we possibly can. Hint, hint, great place to contribute. There's a nice framework for it. It's easy. I'll show you tomorrow. GoVendor and GB are high on that list. We want to get as many in as we possibly can. The main workhorse command, though, is dep ensure. And I want to spend a little bit of time on this because this is where you're going to be spending your time. So ensure is all about this model that we have of the way that we think about this overall system. It's the four-state model. The four states that matter are your project code and the imports in it, the gopackage.toml file, the gopackage.log file, and your dependencies currently in the vendor directory. The way that ensure roughly works is it says, OK, there is a function, basically, that takes as its inputs the imports plus the rules from the toml file. And that function, they go, and the output of that is the log file. And then there's a relationship between the log file and the vendor directory, especially that we want the vendor directory to contain exactly and only what is specified in the log file. So ensure is about making sure that these states are in sync according to these defined relationships. We're not as good as I want to be at the lock vendor directory because details, we're working on it. We have a plan, it will happen. But we're very good right now at being able to very quickly say, oh, your lock file is out of sync with these inputs. Ensure's whole design and the fact that we can have just the one command is the idea behind a general principle, a sync-based tool. This is intended to distinguish it from tools that require the user to do a bunch of sort of manual state manipulation. Oh, move this thing over there, make sure that this dependency is present or something that says, no, you have a bunch of ways that you declare what your requirements are, and it works that out. And if that outcome isn't right, then it's because you've got to change your inputs. So instead of a bunch of finicky management of lower level details, you focus, it keeps the system in sync. Side note, the principles behind a sync-based tool have been leaking elsewhere. NPM 5, which was released a month and a half ago, I think, has a bunch of principles from the sync-based model in it, and NPM 6 is likely to have even more. Basically, sync-based tool is a way of saying that this is an opinionated tool, quite opinionated. In fact, so opinionated that I wrote Ashley McNamara a letter asking her to help us anthropomorphize a little. So this is Digby. Digby is a package managing Gopher. He's like part librarian, part accountant. He really, really likes things being well ordered and in their proper place. And he can get a little finicky about it, but hot damn, man, he keeps that house in order. So if you want to think about why we actually chose the word ensure, it's basically this sentence, right? Hey, Dep, ensure everything is shipshape. Digby does his thing, and all my imports are satisfied, my build is reproducible, and my dependencies are in my vendor directory, and I'm not thinking about details of it beyond that. OK. That's Dep. Dep is at the center of where we are in this overall arc right now, but it is not the end goal. The end goal is the tool chain, of course. The goal is that Dep should not need to exist because the relevant behavior has been moved into the tool chain. And this is where the meaning of that word official experiment really is key. When I say official experiment, what I mean is we are very carefully looking at how to take what is in Dep and map it into what we want in the tool chain. It is the thing we are experimenting on, and then making that clear mapping over to what the tool chain will eventually be. This does not necessarily mean that there is going to be a one-to-one conversion. There may not be a go ensure. Maybe, maybe not. But if not, it's because that behavior has been absorbed into implicit behavior within go list, go run, go build. So Dep is a stepping stone. It's what we focused on now, but we are actively hoping that we can phase it out when the toolchain itself is ready. Until it is, Dep will work. This does highlight something, though. So package management is hard, in the first place. And this would be hard if it was just the Go team working on it. But we are also in a situation where, for the first time, we are looking at incorporating just huge swaths of code from the community into the core of the language. That is its whole own territory that we're trying to figure out. And Russ talked about this yesterday, is wanting to figure out what these avenues for certainly feedback and from experience reports are. But in any case, this is uncharted territory. We are doing everything we can to sort of, put signposts by the way as we go so that moving into the future, this is a path that will be easier for others to walk. But okay, so when we think about what the toolchain is going to look like, there are some key insights from DEP, and this, looks an awful lot like that, slide from before on the DEP fundamentals. Two-file system, imports are in charge, still sync-based, still doing vendor tagging. Vendor is likely to change. It's going to stick around, but what we've been discussing, and Russ has actually prototyped, is the idea of a sort of third space. Instead of being just GoPath, which is the unversioned list of all packages, or vendor, the encapsulated thing within a project, a third space would have versioned sets of packages on disk, just written out. And this is something then the compiler would be able to read, and Go imports can read, and Go Guru can read, and all the tooling can read. So it works something like we have a lock file, and it says which versions you're supposed to compile with, and then that's enough information that you don't need a vendor directory because it will just go find those packages in the third space, whatever it ends up being. So the rough idea. We have a ton of to-dos. Most of this is just orthogonal to the work of moving into the toolchain. We want help, please. The multi-project workflow is helped a lot by this third way, or this third space. That's a situation where I'm working on project A and also project B at the same time, and A imports B, and I want to use those recent changes in B, but DEP right now will just pull what's upstream from B, not what's in your local Go path. Having a third space will help us address that. We need a December suggestion tool. Has anybody used Elm? They know about Elm package and how it tells you? Yeah, Elm package is pretty cool. It's like, hey, this is the next version of your code because we analyzed it and here are the rules, and we know that you changed the following things, and so you have to bump, patch, minor, or major. It's quite possible for us to do a similar thing. Basically, we'd be codifying the Go 1 guarantee. We already have some work done on this, but it's something we want presently. I don't want to go through the rest of these, but there's a bunch of stuff. We don't need registries, but there's cool things we can get from them. We want things to work well with editors. There's a lot. So for all of you, the to-dos are please tag your projects December. As I said, Dave has already written up blog posts about how you should do this. If you're not sure, join the vendor channel on Slack. We can help you figure it out. Hopefully we'll get this tool together as soon as possible so it'll be simple. It'll be like, hey, my last release version was 1.1.0, and the tool will go and analyze the exported API from that. And then it'll look at your current API and be like, oh, you changed the following things here, so we'll bump to 1.1.1 or 1.2.0 or 2.0. Convert your projects to DEP. Now. It's production ready. I said it. The files are stable. The guarantee we provide is that the gopackage.toml and gopackage.lock files will be readable by all future versions of DEP. We made that guarantee about 2 months ago. The caveat here is don't script on top of it too much yet, and you may want to hang on to do permanent conversions until we're quite ready to script. We're making some changes to the CLI UI, and so some things that are valid expressions now will not be valid expressions. But the PR is there. It's done except for like another 15 test cases or something like that. So I expect that to be landing in a matter of weeks soon. It's a hackathon tomorrow. You could jump in and contribute. We're super friendly. People in this room have said that we're like the mostest friendliest of the Goist communities. So, you could totally do that, and it would be great. We'd have a ton of fun. And if you want to keep track, I do an updates thing of what's sort of happening with Go, or what's happening with DEP, and where you can jump in, potentially, on my blog. I've not updated that in about a month and a half. I was preparing for this and having some other discussions. But yeah, all right, I'm almost done. But I want to kind of float back up a little bit, and I like pointing people to this. So I figured that the MIT license, or most licenses really, are things that people have read at most once and have probably forgotten in most of their entirety. But this highlighted line here, fitness for a particular purpose, is not something that is guaranteed by our software licenses. This is really, really important. We are all here. We can be here because we make no promises about our software. It might do what I say, but it might not. It probably won't do what I told you that it does. It probably won't do what you think that it does. We can't have communities without this, and we can't do it because software is fundamentally difficult and complex, and that underlying reality is never, ever going to change. I hope I don't really need to convince anyone of that. Dependency management matters because when it's done well, it's not that it makes that complexity go away, it's that it organizes it. It makes it more assailable as a problem. It puts some structure. And when dependency management is done really well, taming the complexity, the snarling mess of software becomes a collective task, one that we share the burden of instead of one that we have to do on our own. Now, I believe the tools that we have built live up to that standard, that second standard, and I am really, really excited to see how the community and the Go ecosystem grows as a result. I want to thank, I need to not just do like the sort of normal thank you, like I really, really want to thank the fellow members of the Package Management Committee with whom I have spent all sorts of weird hours and time on Hangouts over the past year. The advisory committee, the authors of other tools who have been, it's not that we've always agreed at all times or that we all agree right now. Like, have you met software engineers? Of course we don't agree. But we have kept this process civil and functional and constructive, and it is seriously amazing that we have gotten as far as we are. I want to thank the Go team for the time that they have invested in us and the trust that they have put in us and what we've put together so far. And again, I want to thank all of you because this is a project that is fundamentally about how we relate, as I said at the beginning. So the participation we've gotten from the community, it's everything. We would not be here without it. So thank you.